Jai Hind students, welcome to my YouTube channel. I hope you all are staying fit, keeping high spirits. Before we start this session, let me tell you about the three simple rules in life. Students, the first rule: if you do not go after what you want, you will never have it. Again I repeat, rule number one: if you do not go after what you want, you will never ever have it. Rule number two: students, if you don't ask, the answer will be always no. Rule number three: if you do not step forward, you will always definitely be in the same place. So, you need to keep marching ahead. Clear, students? I hope you will implement all these rules in your actual life, right? So with that hope, let's start this session. Today we are going to discuss a very important and interesting topic of Earth's magnetism. We all are aware that Earth possesses its own magnetic field. There are several evidences of Earth's magnetic field as well. So, let's discuss about some of the evidences. How can we say confidently that Earth has got its own magnetic field? There must be some evidence, right? Let's talk about few of those evidences. First important evidence is, students, you are aware, whenever a dipole, that is a compass needle, suppose this is the north pole and this is the south. So whenever it is under the influence of some external magnetic field, then what happens is it experiences a torque, isn't it? We have done this article. I repeat, whenever a bar magnet or a magnetic compass needle is under the influence of external magnetic field, then it experiences a torque. And this torque will tend to rotate the dipole or the magnetic compass needle, and it will tend to align itself along the direction of the external field. This concept we are very much aware of, right? Now it is found that when a bar magnet or a compass needle is freely suspended, then what happens is it tends to align itself in a particular direction. Now the alignment of the freely suspended bar magnet in a particular direction verifies the fact that there must be some external magnetic field under the influence of which it must be experiencing torque, and accordingly it is aligning itself along that external magnetic field. And students, that external magnetic field is the magnetic field due to Earth. Clear, students? There are some other evidences as well. Now we are aware of magnetic field lines. If you take a bar magnet on a wooden plank, if you try to draw the magnetic field lines with the help of a small magnetic compass needle, then you will find that there are certain points where there is no magnetic field. The net magnetic field is zero. And those points are known as neutral points. Now, at a particular point, if only the magnetic field of the bar magnet were present, then the net magnetic field at a point can never be zero. The net magnetic field at a point due to a bar magnet and under the influence of external magnetic field can be zero only when the magnetic field due to the bar magnet is balanced by some external magnetic field. So it's verified, experimentally verified, the existence of neutral points. And the existence of these neutral points validate the fact that there must be some external magnetic field which must be balancing the magnetic field due to the bar magnet. And thus, due to the cancelling out of the effect of each other, the net magnetic field at the point becomes zero. And those points are known as neutral points. So existence of neutral points again suggests the existence of external magnetic field, and that external magnetic field is the magnetic field due to the Earth. Now, cause of Earth's magnetism. Why? the presence of magnetic field due to the earth. What causes the earth's magnetic field? Students, there are various theories. But till now, no theory is 100% correct. I mean, there are researchers still going on, right? So there are some theories which again we'll be discussing, some logical theories, right? Actually, we are aware all the substances are made up of atoms and molecules. Each atom is made up of a central positive core known as nucleus surrounded by a cloud of electrons. So essentially, all the substances are made up of charged particles, protons and electrons, isn't it? Now, whenever a substance rotates, then what happens? It will constitute current. And current, whenever there is current, then magnetic field will be established around its vicinity. So basically, the most logical reason for the existence of Earth's magnetic field is that the Earth's core contains molten charged metallic fluid. Now, due to the rotation of the Earth about its own axis, so those fluid come in motion and constitute currents, convection currents. So as a result of those currents and due to the effect of Earth, that is known as the dynamo effect of Earth, the Earth has got its own magnetic field. So anyway students, I have selected a short video which definitely will be liked by you, and let's watch this video first and then we will discuss some very important terms and definitions related to Earth's magnetism. So here the video is.
No one has ever taken a journey deep down into the heart of our planet. Now we know magnetic field is generated in the deep down Earth's core. The scientists, by studying the way shock waves from earthquakes travel through the planet, have worked out its likely structure. The Earth's core has a radius of about 3500 km, up to a distance of about 3 into 10 raised to power 4 km, which is 5 times Earth's radii. The magnetic field is entirely due to Earth's magnetism. At larger distances, the motion of the ions influence the Earth's magnetic field. The motion of the ions is affected by a thin hot gas expelled by the sun called solar wind. Since every substance is made up of charged particles, that is protons and electrons, hence a substance rotating about an axis gets magnetized. The core of the Earth possesses molten charged metallic fluid. The fluid motion there generates electric current. The motion of the fluid is sustained by convection and driven by buoyancy. Earth's magnetic field is thus caused by dynamo effect. And the gases in the atmosphere are in the ionized states. The high energy radiation coming from the sun ionizes the atoms in the upper part of the atmosphere. The radioactivity of the atmosphere and cosmic rays also ionize the gases in the atmosphere. Hence, due to the rotation of the Earth, strong electric currents flow. Due to the action of these currents, the Earth is magnetized. Earth's magnetic field is 3.5 billion years old, and since then it has shielded and protected every form of life on Earth from the sun's harmful cosmic radiations.
So students, I hope you have enjoyed watching this short video about the cause of Earth's magnetism. So what we have discussed is Earth's magnetism can be considered to be due to the presence of molten charged metallic fluid inside the core of the Earth. And as we are aware, all the substances are made up of charged particles, protons and electrons. And thus, when the Earth rotates about its own axis, then what happens is a convection current is set up, due to which magnetic field is established around its vicinity. There are some other reasons also which influence the magnetic field of the earth. That also we will discuss, right? So students, now in order to understand Earth's magnetism in detail, we need to make ourselves familiar with certain terms and definitions. So these are the terms and definitions I am talking about. Geographic axis, geographic poles, geographic equator, geographic meridian, magnetic axis, magnetic poles, magnetic equator, and then magnetic meridian. So we will discuss each and every term one by one, right? So first and foremost, as I have stated, Earth is having rotational motion about its own axis as well as it revolves around the sun, isn't it? It's having spinning motion as well as orbital motion. So there is an imaginary line about which the Earth rotates, and we all are aware, students, the sense of rotation of the Earth is from west to east. It is from west to east, and it takes about 24 hours to complete one rotation about its own axis. That axis about which the Earth rotates, that is known as the geographic axis. I'll explain with the help of this diagram. Suppose, friends, this is the Earth. So Earth is suppose rotating about this axis. This is the imaginary line about which the Earth rotates. And as I've told you, the sense of rotation of the Earth is from west to east. This is geographical north, this is geographical south, this is geographical west, and this is geographical east. So the sense of rotation is from west to east, like this. And it rotates about its axis with angular speed of 2 pi by t. And t is the time period, which is about 24 hours. So this line, this imaginary line about which the Earth rotates, that is known as geographic axis. So this is the geographic axis. So what will be the definition of geographic axis? It is the imaginary line about which the Earth rotates, and the Earth rotates about its axis with angular speed of 2 pi by capital T. Capital T is the time period which the Earth takes to complete one rotation, which is approximately 24 hours, right? Now geographic poles. Now look, these are the 2 points on the Earth's surface through which this imaginary line passes. So these 2 points on the Earth's surface through which the geographic axis passes through are known as geographical poles, right? This is known as the geographical North Pole. I'm denoting it by GN, geographic North Pole. And this one is the geographic South Pole. Clear, students? So the points on the Earth's surface through which the geographical axis passes through are known as geographical poles. Geographical North, and this one is geographical South. Next is geographic equator. This is also a term which we are very much familiar with. A great circle on the Earth's surface whose plane is perpendicular to the geographic axis. Right? So, if this is the center of the Earth, then I am talking about this great circle. This great circle. Its plane is perpendicular to the geographic axis. Its plane is perpendicular to the geographic axis. So this great circle on the Earth's surface, the plane of which is perpendicular to the geographic axis, is known as geographic equator. This is known as geographic equator. Clear, students? And geographic meridian. It's an imaginary vertical plane which is assumed to be passing through the geographic axis. So any imaginary vertical plane passing through the geographic axis is known as geographic meridian. Right? Suppose this is the earth, right? This is any point on the earth's surface. Here the geographical meridian would be a plane which contains this point as well as this geographic axis. So any vertical plane at a place which contains that point as well as the geographic axis, that may be termed as a geographical meridian. Clear, students? So again, I must repeat all these four. Once you are thorough with these four terms, the next four terms will be very simple to understand, right? So let's again start with geographic axis. It is the imaginary line about which the earth rotates. The sense of rotation of the earth is from west to east, right? So the axis about which the earth rotates is known as its geographic axis. Geographic poles. Now this is the imaginary line which will pass through these 2 points on the earth's surface. These 2 points on the earth's surface through which the geographic axis passes are known as geographic poles. Geographic North Pole and this is geographic South Pole, right? Then geographic equator. This great circle, obviously on the earth's surface, whose plane is perpendicular to the geographic axis. That is known as geographic equator, or simply we say equator, right? So this is the geographic equator. Geographic meridian, students. It is an imaginary vertical plane passing through the geographic axis. So at any place on the earth's surface, the geographical meridian would be a vertical plane which contains that place, that point on the earth's surface as well as the geographic axis. So that imaginary vertical plane may be termed as geographical meridian or simply geographic meridian, right? So we are thorough with these 4 terms. Now let's concentrate on the next 4 terms. And before that, students, as we have discussed, William Gilbert suggested that Earth, obviously it can be assumed to behave as a magnetic dipole. Earth has got its own magnetism. We have discussed some evidences of that, right? So, in order to understand Earth's magnetism completely, William Gilbert suggested that it can be assumed as if there is a huge bar magnet lying inside the core of the Earth. Actually, there is no such bar magnet. It is just that we are assuming it so as to make the concepts that much more clearer, right? So again I repeat, students, it can be assumed that the Earth's magnetic field is due to a huge bar magnet lying inside the core of the Earth, right? This is just an assumption. We have discussed the actual causes of Earth's magnetism, right? Actual theory that we have discussed. Still, there are some experiments going on to reveal the actual picture of Earth's magnetism. But William Gilbert, in order to understand the concept of Earth's magnetism, considered Earth to behave as a magnetic dipole, and thus we can assume as if a huge bar magnet is lying inside the core of the Earth, right? This is the huge bar magnet I am talking about. This is just an assumption, nothing else. Now students, very important concept. We have discussed the directive property of a bar magnet. Now suppose this is a bar magnet. This is black cap. Suppose it represents North Pole and this represents South Pole, right? Now when it is freely suspended, then what happens is, whenever, we have discussed again in the previous lecture, whenever a magnetic dipole is under the influence of some field, some magnetic field, external magnetic field, then it experiences a torque, and that torque makes the dipole to align itself along the direction of the external field. Is it clear? We have done it, isn't it? So, what we can do is, it's a simple experiment, just suspend freely a bar magnet. Now here again, freely suspended bar magnet. I must stress on this particular term, freely suspended. What do you mean by this freely suspended? Have you thought of a ceiling fan? It is not freely suspended. It can rotate only in the horizontal plane. Now consider a wall fan. It can rotate only in a particular plane, which is normally the vertical plane. But here, freely suspended bar magnet means, suppose it is suspended freely, then it can oscillate in the horizontal plane, this is the horizontal plane, as well as it can move in the vertical plane as well. So that is when the magnet is said to be freely suspended. Clear? So, when a magnet is suspended freely, then it aligns itself in a particular direction. When a magnet can align in a particular direction? Only when it is under the influence of external magnetic field. And in this case, the external magnetic field must be the Earth's magnetic field. So it is observed that when a bar magnet is suspended freely, then it aligns itself like this. After oscillating, then it aligns itself along this direction. This is the north pole of the freely suspended bar magnet. So it aligns itself approximately along the geographical north-south. Approximately along the geographical north-south. Not exactly along the geographical north-south. So when a bar magnet is suspended freely, it aligns itself approximately along the geographical north-south. But exactly along the axis of the huge bar magnet, which is considered to be inside the Earth's core. Now, students, please concentrate. This is the north pole of the bar magnet. It must get attracted towards the magnetic south of the Earth. And the south pole of the bar magnet, freely suspended bar magnet, must get attracted towards the magnetic north pole of the Earth's magnet. Is it clear? So since a magnet when suspended freely aligns in a particular direction, from there we can safely conclude that the place or the direction in which the north pole of the bar magnet directs, that must be the magnetic south of the Earth. And the south pole of the freely suspended bar magnet must point towards the magnetic north of the Earth, because like poles repel each other or like poles attract each other, and also this magnetic dipole under the influence of Earth's magnetic field will tend to align itself along the direction of the Earth's magnetic field. Clear? So, this must be the magnetic south and this point must be the magnetic north. This is Earth's magnetic south pole, this is Earth's magnetic north pole. And this is the huge bar magnet which is assumed to be lying inside the core of the Earth. Again I repeat, students. Suppose a bar magnet is freely suspended, it will oscillate freely and then it will align itself along the direction of Earth's magnetic field. Clear? Suppose this is the north pole of the freely suspended bar magnet. It means that should be the Earth's magnetic south. And this is the south pole of the freely suspended bar magnet. It means that it should be exactly towards the magnetic north. So that is what I stated over here, right? So it must be exactly oriented along the magnetic north-south of the Earth and approximately along the geographical north-south. So now after discussing all these things, now we are in a position so as to define these terms. So let's start with magnetic axis. Students, just now we have discussed Earth behaves as a magnetic dipole. It can be assumed as if a huge bar magnet is lying inside its core. The axis of that imaginary bar magnet is known as magnetic axis of Earth. So this is the imaginary huge bar magnet and the axis of this huge bar magnet. It can be considered to be the magnetic axis. This is, students, the magnetic axis of the Earth. Magnetic poles, simple. These are the 2 points on the Earth's surface through which the magnetic axis passes. So these 2 points on the Earth's surface through which the magnetic axis passes are known as magnetic poles. Magnetic south and this is magnetic north. Right? Remember, magnetic south would be near geographical north. And they are never coincident. Geographic axis, do not coincide with the magnetic axis. There is a certain angle, and this angle keeps on changing. Presently it is about 11.5 degree, and this angle keeps changing with time and conditions, right? So this is not constant. Next is magnetic equator. It is a great circle on the Earth's surface whose plane is perpendicular to the magnetic axis. Students, look, this is the magnetic axis. So a great circle on the Earth's surface whose plane must be perpendicular to the magnetic axis. That is known as magnetic equator. So let me draw it for you. This will be the magnetic equator. This is the magnetic axis, and suppose its plane is perpendicular to the magnetic axis. So that is known as the magnetic equator. So this great circle on the Earth's surface whose plane is perpendicular to the magnetic axis is known as magnetic equator. Clear, students? Magnetic meridian, as I told you, it's a imaginary vertical plane. And magnetic meridian is an imaginary vertical plane which is passing through the magnetic axis. So, any vertical plane passing through the magnetic axis is known as magnetic meridian, right? You can imagine this to be the magnetic axis. Suppose this is the magnetic axis and this is the Earth. At any place, if you want to draw or indicate the magnetic meridian, then it should be a vertical plane containing that place, that point, along with the magnetic axis. So that imaginary vertical plane which passes through the magnetic axis is known as magnetic meridian. Clear, students? Again, should I repeat these four? Okay. Magnetic axis, the axis of a huge bar magnet which is assumed to be lying inside the Earth's core is known as the magnetic axis. Magnetic poles, these are the 2 points on the Earth's surface through which the magnetic axis passes through. Magnetic equator, it's a great circle on the Earth's surface whose plane is perpendicular to the magnetic axis. That is known as magnetic equator. Magnetic meridian, any imaginary vertical plane which passes through the magnetic axis is known as magnetic meridian. Right? And once again I must repeat, freely suspended magnet. This is a freely suspended magnet. Whenever it comes under the influence of some external magnetic field, then it will align itself. Due to the torque, it will align itself along the direction of that field. Isn't it? It will align itself along the direction of that field. Isn't it? So, a freely suspended magnet does align itself in a particular direction. It means that it must be under the influence of that external magnetic field, and that external magnetic field is Earth's magnetic field. So students, always remember, a freely suspended magnet always lies in the magnetic meridian. A freely suspended magnet always lies in the magnetic meridian because it exactly points along the magnetic axis. Clear, students? This is the freely suspended magnet. The north pole of the freely suspended magnet is exactly towards the magnetic south of the Earth, and the south pole of the freely suspended magnet is exactly towards the magnetic north of the Earth. So, it aligns itself approximately along the geographical north-south. Understood, students? There shouldn't be any sort of confusion. Clear? So students, I have written the definition of the first four, right? Let us recollect it. Geographic axis, as I have stated, it is the axis about which the Earth rotates. Geographic poles, the points on the Earth's surface through which the geographic axis passes through. So these are the 2 points which are known as geographical poles. Then geographic equator. This is the geographic equator. It is actually defined as a great circle on the Earth's surface whose plane is perpendicular to the geographical axis. Then geographic meridian. Any imaginary vertical plane passing through the geographic axis is known as geographical meridian. For example, students, let's take the reference of this diagram. I am at this place. I am at this place. So, what will be the geographical meridian at this place? Which plane, which imaginary plane I would call as geographical meridian? What I do is, I will just imagine a vertical plane which must pass through the geographic axis, and it must also contain this point, right? So, this will be it. This can be considered to be any vertical plane. This is any imaginary vertical plane. Now, this imaginary vertical plane contains this place as well as the geographic axis. So, this plane is known as geographical meridian. I hope you have understood this. Now, similarly, the next four can be easily defined. Magnetic axis. It is the axis of the huge bar magnet which is assumed to be lying inside the Earth's core. Magnetic poles, these are the 2 points on the Earth's surface through which the magnetic axis passes through. Magnetic equator, great circle on the Earth's surface whose plane is perpendicular to the magnetic axis. And magnetic meridian, again, a vertical plane. Suppose at the same place I want to imagine a magnetic meridian. So what I do? This will be the vertical plane which should pass through the magnetic axis, which must contain the magnetic axis as well as this particular place. So any imaginary vertical plane which passes through the magnetic axis is known as the magnetic meridian. So students, I hope you have understood the entire concepts. These are the terms and definitions which I will be frequently using in the subsequent topics, right? So do join me in my next lecture where we will be discussing a very important topic of magnetic elements of Earth. So till then, goodbye and do take very good care of yourself. Thank you.